So hello students, how are you? I hope you are fine. So here we are with our revision plan of physics for 12th class. So in this session, we are going to learn about the electrostatic most important concept. And also we are going to see some PYQs, which is relatable to that concept. Okay. So it will get you a better idea that how to solve a question based on that particular concept. Got it? So and one of the thing, the revision is the most important thing in the part of study. So if you learn anything and you do not revise it, then it is a waste of time. Okay. So we are here to utilize that time. So without wasting so much time, let's get started with it. So first of all, the electrostatic topics we have chosen. So here are the some concept that we are going to deal today. Hello, JNV Nizamabad. How are you? So make sure the screen is visible to you and I'm audible to you. So today we are going to do the revision of electrostatic, and that is the plan we are going to follow for next 30 days. Okay, we are selecting some topics, revise that concept and going to the PYQs of that particular concept. Okay, that will help you to revise all the concepts, the most important one, and you have an idea that what kind of question can be asked. Okay, so today we have selected some topic from electrostatic. So the topics are the Coulomb's law, okay, electric field due to the point charge, electric flux, Gauss law, electric field due to continuous charge distribution, and electric field due to a dipole. So one by one we are going to see the concept and the formula also, and solve some numerical on it. Got it? Now, so Coulomb's law, if I talk about, Coulomb's law says that two charges, and there are two charges in the system, and they are separated by a distance r. Let's say the charges are q1 and q2, and they are separated by a distance r, let's say. So Coulomb's law says that the force between them is directly proportional to the product of charges and is directly proportional to the square of, inverse of the square of the distance between them. Okay, if you combine them, it will give you constant. To remove this proportionality sign, k q1 q2 by r square. This k is nothing but, this constant k is nothing but 1 upon 4 pi epsilon naught q1 q2 by r square. So this is the force experienced, not the force exerted. But in vacuum you will say this is for vacuum. Okay, now if these charges are present in a medium rather than other than the vacuum, so let's say this q1 and q2 are placed in a medium, let's say having dielectric constant k. Okay, now and they are separated by a distance r, then what is the force experienced? Because now this medium also exerts a force on this, okay, charges. So the experienced force will get different from this scenario. Okay, so force experienced here is, I'm writing the formula, it is 1 upon 4 pi epsilon naught k. K is the dielectric constant. Do not confuse with this k. This is the constant and this is the dielectric constant. Dielectric constant. Okay, so 1 upon 4 pi epsilon naught k into q1 q2 by r square. You can see this, that force experienced in a medium of dielectric constant k is 1 by k times force experienced in vacuum. So try to remember this. Okay. Also, if I like to add some point on Coulomb's law, this force that is we have derived with the help of Coulomb's law is a central force. It is a central force. Second, it can be both attractive and repulsive. Attractive and repulsive. So both kind of force you can have. Okay. So Coulomb's law says that force is directly proportional to the force experienced by the charges present in vacuum. I have considered. So the force experienced by the charges is the product directly proportional to the product of charges. Secondly, it is directly proportional to the inverse of the square of distance between them. The distance between them is r. You take the inverse of it and get a squared. So it is 1 by r square. If you combine them, then you will have F is equals to K Q1 Q2 by R square, where K is a constant. The value of this constant is 1 upon 4 pi epsilon naught. Okay, where epsilon naught is the permittivity of free space. Now, if these charges are present in a another medium rather than vacuum, so this medium is different from vacuum, and this medium has a dielectric constant K. So we know that the force experienced by the charge will become 1 upon 4 pi epsilon naught K Q1 Q2 by R square. Similarly, if you compare it with the force in vacuum, so you will get 1 by K times force in vacuum. Do not confuse with this K by this K. Okay. These are different. If you talk about the properties of this force, so this is the central force. It can be both attractive and repulsive. Got it? Coulomb's law is only applicable for the bodies which has a point charge distribution. Got it? Now, if you see this question, a 10 microcoulomb charge is divided into two parts and placed at 1 centimeter distance so that the repulsive force between them is maximum. The charges of the two parts are what we have did. We have a charge of 10 microcoulomb. We have divided it into two parts. Okay, and then we have separated these charge particles by a distance of 1 centimeter so that the force between them, and why it is repulsive, because the charge is same. So repulsive forces between them is maximum, then the charges will be. This is a very simple question if you go by the tricks. Okay. Now, if I talk about the solution of this, now you have a 10 microcoulomb charge. Let's say capital Q here is 10 microcoulomb. You have separated it into two parts, let's say Q1 and Q2, so that Q1 plus Q2 is nothing but 10 microcoulomb. Got it? You know that force experienced by Coulomb's law is nothing but 1 upon 4 pi epsilon naught Q1 Q2 by R square. You have R is equals to 1 centimeter. You have to convert it into meter. So it is 1 into 10 raised to the power minus 2 meter. Put the value 1 upon 4 pi epsilon naught Q1 Q2 is, let's say this is Q1 and Q2 divided by R square is nothing but 1 into 10 raised to the power minus 2 whole square. You will see this force is directly proportional to the Q1 Q2. So for this force to be maximum, this product should be maximum. Okay. We know that the summation of these charges is 10 microcoulomb. Okay. The charges can be 1, 9, 2, 8, 3, 7, 4, 6, 5, 5, and rather other than, if you get it 6, it will become 4. If you get it 7, it will become 3. If you get it 8, it will become 2, and similar 9 will become 1. So you need to check that which of the product of these charges is maximum, because if the product is maximum, the force experience is maximum. Got it? So I will tell you the concept. If there are two number a plus b and their sum is constant, okay, so the maximum product of them will be occur, AB will be maximum when A is equals to B. Okay, you can check it here. 1 into 9 is 9, 2 into 8 is 16, it is 21, it is 24. If the charges are same, 5 into 5, it will become 25, and rest other are less than 25. Okay, so the charges will be distributed as 5 microcoulomb and 5 microcoulomb. Okay, try to learn this concept. The option B is the correct option. Got it? I hope you got it. If you have any kind of doubt, you can write it in the chat box. Now, if two charges Q1 and Q2 are separated with a distance d and placed in a medium of dielectric constant K, what will be the equivalent distance between charges in air for the same electrostatic force? Okay. So in this question, two charges are given, Q1 and Q2, and the distance between them is d. And they are placed in a dielectric constant K. I have talked about it. So what will be the equivalent distance between charges in air for the same electrostatic force? Which means you have placed these charges. This is the dielectric constant K medium. This is Q1 and Q2. And here they are in vacuum. So the force experienced by them will be same. So we need to calculate that distance. So we know that force experienced in a medium K is 1 upon 4 pi epsilon naught K into Q1 Q2 by R square. Okay, equivalent distance we have to find out, and force experienced in vacuum is nothing but 1 upon 4 pi epsilon naught into Q1 Q2 by R square. In the question, it is given that the same electrostatic force, which means same force is experienced in dielectric constant, same force is experienced in vacuum. So you need to equate this so that 1 upon 4 pi epsilon naught K Q1 Q2 by R square is equals to 1 upon 4 pi, and let's say in vacuum the distance is d, because the distance will differ, na? So 1 upon 4 pi epsilon naught Q1 Q2 by d square. So 1 upon 4 pi epsilon naught will cancel, Q1 Q2 will also cancel. So you will have KR square is equals to d square. Okay, and let's say here this distance Q1 Q2 is d. Okay, and let's say we have considered it R. Here we have considered it R, so no problem, we have considered it d now. Okay, so this will become KD square and this will become R square. So you will see that R is nothing but d root K. So in vacuum, you need to put that charges at a distance of d root K, so that you have same force experienced as of this if you place these charges on dielectric constant K. So option A is the correct option. Now, 2-point charges A and B having charges plus Q and minus Q respectively are placed at a certain distance apart and force acting between them is F. If 25% of charge of A is transferred to B, then force between the charges will become. Okay. This question has been asked in NEET 2023. So the latest question. So we know that initially the force between them is nothing but K Q1 Q2, which is plus Q and minus Q, so K Q square divided by the distance between them, let's say D. So it will become D square. So this is the force initially present between them. This is plus Q. This is minus Q. The distance between them I have considered as D. So this force will be attractive in nature. Okay. Now 25% of this charge A, this is plus Q, and this is B, which is minus Q. So 25% of this charge will be transferred to this charge. Okay. So what will happen when you transfer the charge from this positive one? It will make this negative charge less negative. And how much? By 25%. So this charge is also reduced. Let's say Q dash will be Q minus 25% of, which is 25 by 100 into Q. So it is nothing but 1 by 4. So this charge will become 3 by 4 times of Q. Got it? Now, this negative charge Q dash will become minus Q, and it is added into that 25 by 100 into Q. So Q dash negative will become minus Q plus 1 by 4 times of Q. So it will become minus 3 by 4 times Q. Now the force F dash will become K because the distances has not been changed. Only the transfer of charge has been possible, has been given to you. So Q dash divided by D square. Q dash for positive charges is 3 by 4. So K into 3 by 4 times of Q. And for negative charges is also same. That is why I have considered both as Q dash. So it is 3 by 4 times. I'm talking about only the magnitude into Q divided by D square. So this will become 9 by 16 times KQ square by D square. KQ square by D square is F. So F dash will become 9 by 16 times of F. Look how simple is this. Option C is the correct option. You need to grab the information that is given to you, focus on that, and apply the concept that you have learned. Simple. Now, electric field due to a point charge. So we know that if there is a point charge, capital Q, so the electric field at a distance r from this point charge, let's say this distance, this is a point P, which is at a distance of r from this point charge. So the electric field is given by 1 upon 4 pi epsilon naught Q upon r square. So this is the electric field. I am talking about the magnitude, and the direction of it will be, if it is positive, so the direction will be away from the positive charge, and for negative charge it is towards the negative charge. Okay, this is for the point charge. Okay, if there are multiple point charge, let's say Q1, Q2, Q3 are present, and we have to find out the electric field at point P by this system of charge. So that will be given by principle of superposition, which is nothing but that E vector net is equals to E1 vector plus E2 vector plus E3 vector. In this system, we have three charges, so we take three electric field, so that the electric field by this Q1 will not be disturbed by this Q2. Okay, and it is not also disturbed by this Q3. This is also the superposition principle. And the net sum, net electric field, will be given by the vector sum of the electric field by individual charges. Okay, if you give it like for negative charge, it is 1 by 4 times epsilon naught minus Q by r square. If you taking here minus, so you don't need to put the direction on it, because you already consider it minus. Got it? Now, electric field configuration or electric field lines, you can say. So electric field lines are the imaginary lines we draw. Imaginary lines which told us about, told, just a second, it told us about the direction of electric field at a particular point. Direction of electric field. Okay, how? So if this is the electric field lines, so you need, if you want to calculate the direction of electric field at this point, so what do you need to do? You have to draw a tangent which is touching this point. So the electric field is given by the tangent drawn at the curve at that particular point. Got it? So we would see the different variation of this imaginary lines. So for positive charge, it is moving radially outward. For point charge, it is radially outward if the charge is positive. So positive point charge, for positive point charge, it is radially outward. It is radially outward. Okay. For negative point charge, it is radially inward. Okay. I hope you are getting this. If you have any kind of doubt at any point of time, you can ask in the chat box. Okay. Now, this is for the negative point charge. Negative point charge, and it is outward, radially outward. Got it? For line charge, this is a line, and let's say it is positively charged. So for this distribution, the electric field lines passes perpendicular to it, like this. Okay. Hello, Samsung Lab 2, how are you? So for line distribution of charge, the electric field lines be like this, perpendicular to the line. Got it? Now, one of the most important property of this electric field lines is that they do not make closed curve. Okay. So if I talk about this positive charge placed along with negative charge, so electric field lines will go radially outward from this, but it is attracted to this, like this. You can see. So these are the distribution of this electric field lines. Got it? And for here, it is radially inward for negative charge. So you can see here, these are not making a closed curve. Here it is in clockwise direction, but here is also in anti-clockwise direction. So they are restricting to be a closed curve. Got it? So they do not make closed curve, and they do not cut their self. Because if two electric field lines cut or intersect with each other, so what will happen at the point of intersection? You have possibility to draw two normals or two tangent to that point in the direction of this, in the direction of this. So at that particular point, the electric field cannot be in two directions. That is why two electric field lines can never intersect with each other. Okay. Now, the question, try to solve this question. A point charge of 10 microcoulomb is placed at the origin. At what location on the x-axis should a point charge of 40 microcoulomb be placed so that the net electric field is 0 at x is equals to 2 centimeter? This is the most asked question in JEE and NEET. So please focus on that, on this question. And try to learn the concept behind it. So what do we have? We will consider an axis. This is y-axis, x-axis. So this charge of 10 microcoulomb is placed at the origin. We will move according to the language of question. At what location on the x-axis should a point charge of 40 microcoulomb be placed so that the net electric field at x is equals to 2 centimeter on x-axis will be 0. So let's say we have placed this 40 microcoulomb charge here at a distance of x from this origin, and at x is equals to 2, x is equals to 2 centimeter, the net electric field E net here is equals to 0. We know that electric field by this point charge is given by E is equals to kq by r square. So for 10 microcoulomb, let's say it is E1 for 10 microcoulomb, and for 40 microcoulomb it is E2. So what we will do, we will find this value of E1 and E2 and equate to each other, because at this point E1 is equals to E2. This is a positive charge. Okay. Let's say the distance by this point to this point at for 40 microcoulomb, it is x minus 2, because this distance is 2 centimeter. This complete distance is x centimeter, so it will become x minus 2 centimeter. Got it? So what we will do, we will find the expression of electric field for this point charge, point charge 1 and point charge 2, and equate them at x is equals to 2. So for this point charge, this point x is equals to 2 will exactly at 2 centimeter. So E1 is equals to k 10 microcoulomb divided by the distance ka square. Distance is 2 centimeter. It is 2 centimeter. So 2 into 10 raised to the power minus 2 meter square. Okay. For E2, this point is at x minus 2 centimeter. So it is k into 40 microcoulomb. I am not converting into coulomb, because if you convert it and if you equate it, this will automatically get cancelled. So you don't need to worry about it. 40, sorry, the distance is x minus 2 times 10 raised to the power minus 2 centimeter square. Now at x is equals to 2, E1 is equals to E2. So E1 here we have k into 10 divided by E2, 4 into 10 raised to the power minus 4. This will we have E2 k into 40, x minus 2, 10 raised to the power minus 4. So it will get cancelled out. K and k will get cancelled out. 1 0 cancel this 0. So you will have x minus 2 square is equals to 4. So x minus 2 you will have plus minus 4. If you take this value plus, so x will become 6 centimeter. And if you take this minus, so this x will become minus 2 centimeter. Okay. So we are not interested in the minus value, we are interested in plus. So x is equals to 6 centimeter. So the distance, if you place this point charge at a distance of 6 centimeter from the origin, so you will have the value of electric field 0 at 2 centimeter. And also at x is equals to minus 2. If you place this on x is equals to minus 2 at LHS of this. But here the given answer is x is equals to 6 centimeter. The correct option is this. If you have any kind of doubt, you can ask. No? Okay. So this is the important question. A uniform electric field E is equals to 8 m upon E. This is the value. Okay. 8 m by E. Volt per meter is created between two parallel plates of length 1 meter. Okay. An electron enters the field symmetrically between the plates with a speed of 2 meters per second. The angle of deviation theta of the path of electron as it comes out of the field will be. So we have two plate here. The direction of electric field is in this direction. We know that the electron will experience a force opposite in the direction of electric field. Okay, so this is the direction of electric field, and this is the direction of force experienced by this electron. Okay, we know that force experienced by this electron is nothing but q times E. The magnitude of charge is E, let's say, and it is capital E, which is the electric field. If we calculate, we know the Vx. We know the Vx is equals to Ux, because in x direction there is no acceleration, there is no force acting in the x direction. So this velocity in x direction will remain constant as 2 meter per second. But there is a force in vertical direction. So we need to calculate the Vy, because to calculate this deviation, we need the formula tan theta is equals to Vy by Uy. Sorry, Vy by Vx. Okay. We have calculated the value of force, which is F is equals to E. Let's just compare it with Newton's second law, which is F is equals to ma. Put the value of F. E capital E is equals to m into a. So acceleration here is nothing but E by m into capital E. Okay. Now we know that for y direction, if we apply the equation of motion, Vy is equals to Uy plus Ay into T. Okay. So Vy we are able to calculate from this. So Vy is equals to Uy. Initially, there is no motion in vertical direction, so Uy will be 0. Ay we have calculated as E by m into capital E. The time we need to calculate. So we are going to calculate this time. We know that this 2 meter per second square velocity electron have covered 1 meter in the same time to exit from the field. The distance is given you as 1 meter. So Vx is equals to Sx by t. So time will be Sx divided by Vx. Sx you have 1 meter, Vx you has 2. So time will be 1 by 2 second. Now, if you put this time, just a second. If you put this time value in this equation, so Vy will become 1 by 2 times E by m into capital E. Now tan theta is nothing but, if you put the value of capital E also, which is given you as 8 m by E. So this m by E will cancel this E by m, and it will become 8 by 2, which is 4. Okay. So now tan theta is nothing but Vy by Vx. Vy is 4 and Vx is 2. So 2 will be there. So theta will be tan inverse 2. Okay. So this is the correct option of it. If you have any kind of doubt, you can ask. Now, electric flux. So electric flux is nothing but a scalar quantity. It is a scalar quantity, first of all. Scalar quantity. Got it? Now, just a second. So electric flux is a scalar quantity which is a scalar quantity, and scalar quantity means no direction. Simple. Okay. Now, if I want to know the actual meaning of it, so it will be the electric flux is nothing but what? It is the amount of electric field lines passing through a area perpendicular to the direction of electric field. Okay, perpendicular to that particular area. So this is the area we have considered. It is the number of electric field lines passing through this area, which is, you will see, this is placed perpendicular to the electric field, है ना? So it is the number of electric field lines crossing or passing, let's say, passing through an area, okay, perpendicular to the field. Got it? This electric flux is given by phi is equals to E vector dot A vector. So it is also, you can write it, if you open this dot product, it will become EA cos of theta. So this flux will depend on the value of theta, area, and electric field intensity. Like how you have placed this area. Suppose the area is placed is like this at an angle theta, and this is the value of electric field lines. Now what area you have to consider? You have to consider this area. Okay, the angle is this. Got it? So this will become E cos theta, this, and this will become E sin theta. Okay. Now, for if the area is not, let's say, continuous or uniform, or the electric field lines are not uniform, they are varying in nature. So you need to calculate the small flux passing through that, and it will be given by E dot dA. Okay. Then you will integrate it so that you will get the complete value of flux passing through that particular area. Okay. Now, see, for this is the area vector. This is the area vector, and the angle between them is theta. So you have to consider that particular component of the angle which is alongside the electric field. There are two different terms: the electric field, the area vector, and the area itself, the plane. So the plane should be perpendicular to the electric field, but if the plane is perpendicular to electric field, let's say this is the electric field and this is the plane which is at 90° to it. So the area vector is always perpendicular to the surface. So area vector is along with E for the flux. Got it? So here, if you resolve this area, you will have E cos theta, A cos theta, or A sin theta. But you can also resolve, which one is easier for you? You can also resolve this E alongside with this E cos theta. You will take that component of electric field which is parallel to the area vector of that particular plane. Got it? Now, here the phi is equals to EA cos of theta. So phi you can consider E cos theta into A. So this E cos theta is the E parallel to area vector. Here A is the area vector. Area vector you have to consider. Got it? Now, Gauss law. Gauss law tells us about, it gives the direct calculation of the electric field intensity and also the flux you can calculate by it. So Gauss law says that from the flux by a closed surface is given by the charge enclosed by that surface divided by epsilon naught. This is the Gauss law. So if this is the closed surface and here the charges q1, q2, and outside the surface the charges are q2 and q3 and q4. So if you write the flux through this closed surface, the surface should be closed. So phi should be charge enclosed, which is q1 and q2. q1 plus q2 divided by epsilon naught. This is the application of this Gauss law to calculate the flux through the closed surface. Okay. One of the things that you have to notice, you can put this phi as E dot A, Q enclosed divided by epsilon naught. So this electric field in this expression is not only by the charge enclosed in the closed surface, it is by the complete charge distribution. The complete charge, the entire charge that is distributed inside the surface or outside the surface. So it is for both inside and outside. Okay. For application of, to apply the Gauss law, the surface should be first symmetrical. It is easy for you. Symmetrical. Okay. And second, it should be of non shape. Non shape. So for that, we are going to apply this. Now, according to Gauss law of electrostatic, electric flux through the closed surface depends on the area of the surface, the quantity of charge enclosed by the surface, the shape of the surface, and the volume enclosed by the surface. Okay, so we know that flux is depend only on the electric field E dot, which is the electric field or the area. So it is area, surface area of the electric. Got it? Now, in this question, in a cuboid of dimension 2L, 2L into L, a charge Q is placed at the center of the surface S, having area 4L square. The flux through the opposite surface S is given by. So what do we have in this question? We have a cuboid. I'm drawing this cuboid. This is the cuboid we have. Okay. This length is 2L, which is given to us. This is also 2L. And this height is L. So what is given to us? That in a cuboid, a charge Q is placed at the center of surface S, having an area 4L square. So only this surface has an area 4L square or the upper one. So we will place this charge at this surface. You can also place it on the base. So we have placed it at the top. This charge is placed here, let's say. The flux through the opposite surface S is given by. So we need to calculate the flux through this base surface. What we are going to do? We are going to, in these types of question, try to cover this charge. Okay. So what we are going to do? We are going to make a similar cuboid of similar dimension, so that this charge is enclosed inside that. Now you can see this charge is enclosed by this cube, which has a height of 2L also. Okay. And this length is also 2L. This length is also 2L. So this will become a cube now. Okay. We know that by Gauss law, phi is nothing but Q enclosed divided by epsilon naught. So phi here will become, this is Q divided by epsilon naught. Now, there are 6 surfaces in this cube. 1, 2, 3, and 4, and 5, and 6. So there are 6 surfaces in a cube. And this is the total flux from the cube. So for one surface, it should be 1/6 of this total flux. So the total flux will be Q upon 6 times epsilon naught. Okay. So correct option is D. So what you need to do, you need to place a cube of similar dimension and cover this charge, and then you calculate the total flux through that, and by that you need to calculate the surface. By the surface you can also calculate. So from surface, the charge or the flux through any surface of the cube will be 1/6 time of the total flux. Got it? Now, if you have any kind of question, you can ask. The electric field in a certain region is acting radially outward and is given by E is equals to AR. A charge contained in a sphere of radius A centered at the origin of the field. What will be given by? We need to calculate the charge. You need to understand the question first of all. So this is the variation of electric field, which is radially outward, which is given to you. And this electric field varies as AR. Now, there is a charge contained in a sphere. So there should be a sphere of radius A. The radius of this sphere is A and centered at the origin. So origin pe this charge is placed. So we need to calculate this charge. So what we are going to do, we are going to apply the Gauss law, because from the Gauss law we try to calculate the flux through it, and from flux we are going to equate it with E dot A, and E is given to us. So at the surface of this sphere, what should be the value of this electric field at the surface of sphere? At the surface of sphere, it should be, you need to put R is equals to A, because it is varying as R. So A into small a. Now apply the Gauss law. Gauss law says that phi is nothing but it is Q enclosed divided by epsilon naught. The enclosed, we have considered this sphere as a Gaussian sphere. Okay. So charge enclosed by this closed surface is Q. So it is Q divided by epsilon naught. So Q by epsilon naught is equals to phi, you need to put it as E into A. A is the area of the sphere. Now, Q here is epsilon naught E into A. E for this sphere you have already calculated, it is A into small a. So epsilon naught E, for the value of E, it is A into, and this you will consider as A dash, because this A and this area is different. So A, put the value of A dash, this area of this sphere, which is 4 pi square, 4 pi A square, and the value of electric field is A into small a. So this charge will become 4 pi epsilon naught A into A cube. So option A is the correct option. Got it? Now we will kept our revision up to this point. Next of this remaining revision we are going to do in the next session, and I am able to complete it, but you guys have joined late, so try to be on time so that we would cover all the topics that we have in the learning objectives for today. Okay, so from the next class, try to be on time. Got it? So it will help you, because I make to cover all the topics that is important to you and the PYQs related to that. Got it? So try to be on time. If you have any kind of doubt in this session, you can ask me right now. Okay, or you can put this in the chat box if you have any kind of doubt. Otherwise, the lecture is being over. Thank you so much for being attentive. But try to be attentive on time. The time is 3 p.m. So please try to join at 3. Okay.